Okay, this video is for paired samples t-test and jamovi. We have a dietitian that is interested in people's cholesterol levels. This person thinks that if they take this mineral, their cholesterol level is going to go down. Well, actually, that it's going to change it. They don't actually give us a direction. Here we have the cholesterol levels before, and then 6 weeks after they measure the cholesterol level again. So right off the bat, I thought this one's look smaller, but this one's look pretty close. So there might not be that much of a difference just by looking at the data. Here, you need to think about what the independent variable is. Remember, the independent variable is always going to be nominal. And there's no nominal variables here. It is actually because it's kind of, you can think of it as imaginary, or not really. It's just that in jamovi, it just looks better if we have the two measurements in two columns. But basically, the nominal variable here is the before and after. Those are two categories, and it's what's separating our samples. Okay. So let's go to jamovi. Okay, so we are in jamovi. We have the before and we have the after. In analysis, we're going to go into t-test. This one is a pair samples t-test. Notice how it only is going to take continuous variables. So it's only going to take the dependent variables before and after. I have seen students that put like after and then before. Let's actually do it. Do not do this. You will get the same results. It just means that the statistics is going to be different, and technically I will mark it wrong. So just make sure it makes sense. You put before and then you put the after. But the output of the test shouldn't change the whole much. Like if you're going to reject, you're either which one you put either in front or after, it shouldn't change the output of the test. You reject or you don't reject. In tests, you're going to have students. We decided that we just want to see if there's a difference. In additional statistics, I want my confidence interval, so I need to select first mean difference and then confidence interval. Sometimes I see mistakes in the output from students because they select the effect size. We're not covering that, so make sure you pay attention onto what you're clicking. My confidence interval is over here, and that's pretty much what we got as well. I want the descriptives. We could get the descriptives part here, but I'm not gonna lie, they're kind of ugly. When we look at the plots, we can see there's like a decrease, but when we look at the p-value, it is greater than our alpha 0.05, so it's not statistically significant. We want to check normality as well. There's a couple of options, but we're gonna go with QQ plot. That is not normal at all. So you will describe this when you do your data project, like the line is not a 45-degree angle, the dots are not close to that line, they're like all over the place. You know what doesn't help here is that we have a very small sample size. So that's not helping us. Okay.